Hello everyone, my name is Muhammad Umar and I'm here to present our work on compositional learning of image text query for image retrieval. This work was done with my colleagues Igor and Martin at Marketiu. Marketiu is a leading business-to-business e-procurement platform in Europe. In this work, we consider an advanced retrieval system where users retrieve images via a multimodal query. The figure shows a potential application scenario for this task. A user is interested in buying a dress and queries our system with an image of a dress and some natural language expressions describing the desired modification in the query image. The task is to retrieve the image with desired modifications from the database. Now we formalize this task. Here X and T denote the query image and text, and Y denotes the target image. Psi is a pre-trained neural network. G denotes the composed representation, where theta denotes the learnable network parameters, and kappa denotes the similarity kernel. The task is to learn a composed representation of the image text query by maximizing the similarity between composed representation and the target image features. This figure presents the architecture of a proposed model, that is Compose AE. It is an autoencoder-based approach for composing the modalities in the multi-modal query. For the image query, we extract the image features using Resonance 17, and we extract text features using BERT. These extracted image and text features have different statistical properties, as they are coming from independent models. We argue against the commonly followed approach of fusing these features via some fully connected layers. Instead, we adopt a novel approach and map these features to a complex space. We propose that the target image is an element-wise rotation of the source image in this complex space. The information about the degree of rotation is learned from the text features. With such formulation, text features take a central role in defining the relationship between the query image and the target image. We learn the composition of these complex vectors and their mapping to the target image space by adopting a deep metric learning approach. We also propose an explicit rotational symmetry constraint on the optimization problem. Specifically, we require that the multiplication of the target image features with the complex conjugate of the learned rotation should yield a representation similar to the source image features. In addition, we also incorporate reconstruction losses of text and image features in our training objective. They act as regularizers on the learning of the composed representation. Now we quickly glance at the results of our experimental evaluation. We compare the results of Compose AE with several competitive baselines. From these results, we note that Compose AE achieved state-of-the-art results on all three benchmark datasets. This figure presents some qualitative results for Fashion IQ dataset. For both queries, we can observe that all the retrieved images share same semantics and are very visually similar to the target image. In conclusion, we propose a novel method Compose AE to compose the representation of the source image rotated with the modification text in a complex space. We also introduce a rotational symmetry loss in a training objective. Our experiments on 3 datasets show that Compose AE consistently outperforms SOTA methods on this task. The code used in this work can be accessed at this link, or you can scan the QR code. Thank you for your attention.